Talk 2 of BlinkOn. I thank everybody for coming. I'll try to put everybody to sleep here, so get comfy for nap time. I'm Nat Duca. Actually, I hope very few of you know me. My last Blink commit was a very long time ago. I've mostly been behind the scenes of this community working on the compositor. I built early bits of compositor. Mostly these days, I wrangle a lot of the work around 60 FIPS in Chrome. So you'll work a lot with things like tracing, which is the stuff I actually write code for today. It's a little depressing from an engineering point of view, but hey, that's life. So the thing I'm here to talk to everybody about is this vision for 60 FIPS on mobile. We've been trying to get 60 FIPS on mobile for a long time, really since well before Chrome existed on Android. At the time, though, we were really focused on desktop browsers and sort of being able to scroll desktop pages on mobile, right? We wanted to make a great mobile web browser. In the last 6 months, the last 8 months, we've shifted focus a bit, as Eric and Jochen alluded to, which is now we want to make mobile apps, which means really looking at our platform and saying, is our platform able to drive 60 FIPS? Which is a very different thing than making a really great web browser. Now, if you want to take a nap after this, just remember this slide, which is basically, like today you can make a mobile app on our platform, but it needs a lot of life support. It's fragile, and there are a lot of don't do this sort of asterisks attached to the whole thing. Don't add a touch listener here. Don't prevent default this. Oh, definitely don't do pull to refresh. You can't build an application at scale with a big group of engineers with all those don'ts. And so the way things exist now, you can make a small toy app, but you can't make a big thing like a Gmail or really anything beyond a few people and hit 60 FIPS, not without a lot of pain. What we aspire to with mobile at 60 FIPS is that the 60 FIPS experience is an expected and verifiable outcome. Verification is more of a testing thing, so let's ignore that and just talk about expected. It needs to be the case that all the different pieces that go into building a big application all compose well, all behave well, and don't create degenerate performance cliffs like they do today. How hard could it be, right? Yeah, like, okay, let's fix a few bugs and we can go home. So yeah, we can go home. We're done. Except we're not. I think the way to think about this is to return to yesteryear and think about how we got to what architecture exists in the code today. I think the formative moment here is the launch of sort of iOS and it wanting to build a great web browser. There, the assumption, the grounding assumption is that basically the web page is adversarial. It is incurably janky. It's going to go do script for 30 seconds, and you still have to scroll the page, or you have to pinch zoom the page. When you're building a great mobile web browser, and you want to ship it right now, like I need to get iPhone 1 out with a good web browser, you're going to cut some corners as far as the platform is concerned. The core tenet that we see in the data that backs up this basic thing that the web is kind of incurably janky is that rasterization is slow. This is the part that I do agree with sort of that basic thing. That things are really slow. This is the scary one. You might ask a V8 person and they might say something different, by the way. Rasterization is hundreds of milliseconds. This is the process of taking the commands we issue into the graphics context and turning them into pixels. None of these numbers, even the best on the NY Times, is anywhere near a rate that we can sustain 60 FIPS in a happy way. So this then shapes our core architecture that we ship, which is layers. We take the DOM, we try to find the pieces of it that we don't think are going to change, we rasterize into those, and then we have this two-tiered type of content. Interacting with a layer is fast because we just move it around and recompose it. But interacting with DOM that is inside a layer still hits those rasterization costs, and all ye venture here shall perish. So this layer system is our line of defense against jank, and we've even extended it further. And again, following Apple's lead, which was a great lead, we identify the layers automatically, and then we can scroll them. So if the main page goes to sleep, you can build a JavaScript busy loop, and you can still scroll the page up and down. This is a nice feature for a web browser. But now there's a lot of magic going on here. You'll have a page that's literally moving to the eye, and there'll be no on-scroll handlers firing, no RAF firing. This does not make a good platform. It does make a good web browser. We don't even have a way to get to the layer and say, did this div get a layer? We know that they're critical for performance, but they're not exposed to the platform. Yet, we don't want to expose it to the platform because we're constantly changing the rules for making layers. So we've got this bit of a Gordian knot that we've created for ourselves. We know that we need this system because it's our life support, but we also know it's not really right for the platform as far as how it's exposed today. And the core issue really is this issue of what makes a great web browser is not necessarily what makes a great platform. So we thought about this, and we started looking at mobile apps because there's been, increasing sadness about the state of the web for mobile apps. And unfortunately, there's not a lot of content out there to go to. A lot of people have failed, and that's scary. So when we went out looking for people who'd done a great mobile app and that we could profile, we didn't find much. So we wrote some. So one of the more useful ones that we have is this inbox app. And it's off of the key silk cases on the telemetry sort of folder hierarchy. This set of apps plus some Polymer stuff that we looked at, plus some apps that sort of died that we got a hold of internally and externally. So we looked at all these and we started going, all right, what's slow, what's going on here? Let's start forming an opinion about what our platform, what the shape of our platform is today at a performance level. So before I talk about what we found, I want to talk about how we did this, because as Eric alluded to, the most powerful thing that we can do with regard to performance is help all of you agree with us by being able to recreate our methodology. Right? Performance tuning is about shared consensus, and then from that consensus emerges a direction. Tracing is definitely the most common way that we dig into performance issues right now. I think one of the reasons that it is used this way is because it works on every Chrome that exists. So you can get it out of Chrome Shell, you can get it out of Content Shell, you can get it out of weird, wacky things. And so it's a very convenient way to get a bit of performance data and then send it to someone and use that to resolve a debate. We have a trace reading clinic after this in another room where we're going to show you a bit about how to read traces and then invite you to challenge us with some hard sites, and we'll try to tell you why they're slow. That's going to be fun. But the thing to know for now is we all use tracing to get a basic sense of where time's going, and there's some really weird, less known features in tracing that I've listed up here that let you understand not just where time is going, but why. A key part of our platform are these dirty bits, right? So style resolution is proportional to how many nodes were dirtied. And so you need to know for that, not how fast is the style resolver, but which nodes were dirtied and why. And so you can get this out of tracing if you know the right incantations. And again, to know that, you need to sort of socialize with the groups of people that work on this stuff and sort of learn those incantations, because we don't have a central way of supporting that. It's very hacker style. Now, there are some parts of Chrome that are really, really kernel-y, that have tight pieces of code that we know have to run fast. And we've used sampling profiling also to dig in there. Unlike tracing, where you have the same tracing running everywhere, so it's sort of homogeneous, the sampling ecosystem is very diffuse. So we have everything from Hurricane's lightweight sampling that works on all Chromes but only gives you very simple data, to people running instruments and getting sampling data out of instruments, to we have people who run perf on the Android devices and then use the raw data. And then we have other people who realize that that tool's broken and lies to you, and they wrote their own thing that wraps perf. It's a big mess, and it's something that you should all be aware of. We need to make sampling profiler usage just as easy and sort of automatic so that we can all argue about kernel level performance with the ease that we do argue about trace level performance. But we did use this, and this was key for stuff like recalc style and painting performance and GPU performance. One other thing to say about our process, we do have this key silk cases page set, which has 30 or so pages that we think are representative of the workflow, workload that we want to see run faster in Chrome. But it's not exhaustive, so we're always looking for contributions there. And then we have 3 major benchmarks that we stood up that run through telemetry on these pieces of content. We track thread times, which is a measure of how much CPU is used to run that page. So if the CPU is used for 50% of the time, that's strictly better than it being used for 75% of the time. And so that's a useful metric to track. We also track whether it hits 60 FIPS, that's the smoothness benchmark. And finally, we track this rasterize and record benchmark, which says how fast we can paint the page. And since that is sort of the current root of a lot of the evil in the 60 FIPS space, we track it independently. But the reason that I'm really up here is to talk about what we learned about what's slow. So I'll stop yammering about process and return to our goal, which is 60 FIPS apps. Hard goal, let's talk about why it's slow. So we poked into all these traces, and it was pretty friggin' depressing. And it was sort of layers upon layers of depressing, because we'd crack open one and we'd think, oh my God, recalc style is slow. And then we'd really crack that open and we'd realize, oh, actually, no, it's this other thing. And big code base, what can I say? I've just listed a few. The thing is, it's an absurd amount of different issues. And we've struggled to understand them all and categorize them all. So we had this hot list jank, which is all the things that we've sort of filed that we feel are performance that apply to mobile apps. And you can go scrub through that and just have some fun, and you'll see that there are various sub-labels applied that we use to organize out the bugs within that space. And even with that sub-categorization, there are quite a lot. As you can see, there's like 15 different areas. And so for the next little bit of time, I'm going to attempt to summarize all the work that we've discovered within these areas so that you can get a flavor of some of the work you've all seen being done individually in your areas of expertise, so that you've heard of these words like layer squashing. And my goal here is to give you the context of, yes, that ties in the fast mobile apps, and this is the context for it. And then within each of these spaces, there are talks throughout the next 2 days to go into details, because I have no hope of doing that here because of the sheer volume. So Blink gets a whole slide because of the volume. So at BlinkOn 1, we were all pretty convinced or concerned that CSS had us doomed and that layout was just intractably slow because it doesn't have this notion of containment. And we were pretty concerned that style was the same issue, that it was sort of this global problem, so there was no hope of fixing it. And then we really dug into the data, and were surprised to see that that was not actually the first or the second or even the third order problem. It's there in the noise, but it's not the concern. Some of the issues that we found instead were just stuff that had not been optimized because we'd never noticed. The biggest one was what I call layer maintenance. We know that we have to make layers for the compositor to draw, because that gives us our scrolling. And we know we have render objects on the other side, which are coming out of, well, web. The processes that we use to create the layer tree from the DOM, from the render objects, was asymptotically obscene, and would run many times in a frame, and would run redundantly, and do all sorts of crazy stuff, often wrong. And so you'll hear about projects like layer squashing, and the Blink schedule, the Blink state machine, and chicken and egg as all part of this effort to try to make the management of layers and the creation of layers architecturally sane, so that we can reason about it as a community, and faster. That was actually one of the #1 sources of recalc style being slow, because we had instrumented recalc style wrong. So we thought it was recalc style, and it wasn't. But there was some recalc style that was slow, and there's been a lot of work around targeted style invalidation, where you would put a class name on a subtree, and we would recalc the whole subtree, even though only that element changed. We've worked on fixing style sharing, because a lot of properties basically say element.style.foo equals blah, 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 blah. And that would blow up all their style costs. And it was funny, so there's these groups like Famous, right, that love to just say, you know, sorry but no thanks, I'll do the layout myself. So they just put a whole lot of WebKit transforms on all of their divs, and they move everything themselves. They were then getting nailed by this particular bug, which was we were doing full CSS parsing on transform strings. And so you'd think that you were getting good GPU performance by moving things around with style, but your JS performance would go to hell. Literally 4 or 5 milliseconds just in this style parsing. So you'd say element.style.webkit transform equals some string, and then we would spend months in the inside of that. And then another one of these themes of just the integration between our two silos. The compositor needs what's called an SK picture, a display list of the graphics context commands to render a page. And we do that so that when you scroll and you reveal a part of the page that we haven't rasterized, we can rasterize that exposed part without going to the main thread, on the assumption that the main thread is adversarial. But then the cost of getting that picture turns out to be prohibitive in its own right. Something like 25% of the time on the main thread currently is going to this creation of this display list. So we've got work speeding that up currently and trying to make it better, you know, in the future. So one other thing that I thought deserved its own slide on its own is this repaint storm concept. So enemy number one is repainting, and repainting arises from invalidation. Blink doesn't have, or didn't at the time until very recently, have the notion of, did you send into this layout test, did you send a good invalidation? It just had was the final picture correct? So it was always completely plausible to fix a bug before your check-in by just repainting the body. And in fact, that was done pretty often. The consequence of that, back onto 60 FIPS, is that you do something innocent like call click on an element because you need to send an event, and it repaints the element. And then you've got a 40, 50, 60 millisecond jank just because of that. So we're in the midst of trying to unravel and even find all of these accidental invalidations. And there are multiple efforts going on. I think Julien is giving a talk on this tomorrow, if my memory serves. And that's super important because the mental model of our developers, people trying to write to our platform, is if I see it change, I expect to pay a cost. But if I don't see a visual change, I don't expect there to be performance cost. But in our platform currently, you can have these little hidden performance bombs that just destroy you, but they're not intuitive when they come up. So in a different theme, we went and looked at all of our developers who are just trying to write apps, and we saw that they're trying to use CSS animations. So they got the memo that CSS animations can be fast because we can composite or drive them. Unfortunately, they got the memo there, but they then started going through, I would say, heroics to try to drive CSS animations. And it turns out that animation API is evil. So people end up having to do stuff like query computed style in order to figure out if the element's going to move, and then they move it. And this is to work around badness. The problem with this in practice is that then they're starting to force recalcs in the middle of their JS. And so then this compounds, and so then all of a sudden we start thinking that JS is, or that recalc is a bigger issue than it really is, and it just sort of everything balloons and badness results. It's really important that we get people moved off of CSS animation and onto something sane. The same thing is almost certainly web animations. The folks here that work on web anim have been heroically trying to get a minimum subset out so that we can start bringing people to a sane place in this area and get them away from doing all this forcing that's creating jank for them when they're not expecting it. So similarly, under the heading of the platform sort of working against you, we've got all this code in the system that allows you to scroll when the platform janks, and that's to make a great web browser. The problem with this is if you want to do something in response to an on-scroll, you're kind of screwed. The browser may not give you an on-scroll, or maybe it'll give you an on-scroll, but if you don't respond quickly enough, it'll scroll anyway. And this is madness. So we have another group of people, Rick Byers will be talking about this, trying to work through some basic use cases. I've listed 2 here, there are many more. Just trying to make sure that our platform can do this without unnatural acts. The current unnatural act required to create pull to refresh right now is to disable scrolling. You literally put a touch handler and a mouse wheel handler on your page, and then you do all the scrolling in JS. You could argue that that's good in some ways, but I think our consensus was scrolling is part of our platform. And we don't think it should go away. So given that, it should be possible to do scrolling and have scroll-coupled effects. And we then need to unravel all of the complexity around there. And it's not just about on-scroll firing, just to give you some more examples. When you scroll and hit the edge of the document, you might want to fling into the pull to refresh area. So maybe we need an on-scroll or over-scroll event. And even more annoyingly, Chrome has the omnibox hiding. When you scroll up, the top nav hides. That's completely invisible to the platform, as is the on-screen keyboard showing up. Those need to be explained to the platform so that if you're a platform person or a person writing low level to this thing, rather than making a document that you view, you can see this crap happening rather than having to guess it sort of accidentally. So if you rewind back to 2012, 13, I forget, we were all reaching out to the community and saying, hey, could you please stop doing set timeout 8 to animate? Would you please use this great thing called request animation frame? It's really great. And the reasoning that we presented was, hey, you're attached to a screen. Screens have a fundamental refresh rate. So request animation frame prepares you for that refresh rate. It ensures that your production rate is matched to the consumption rate of the screen. It turns out that that was only the beginning of the story, and there's a whole second part of the story to be told. Input devices like mice and touch screens produce input also at a regular rate, but it's not the vsync rate. The trackpad on my Mac, for example, produces input at 8 milliseconds. This is not 60 hertz times 2, it's 8 milliseconds. And so you get this aliasing from the input rate to the screen rate. If you ignore this and you just process input as they arrive, what you'll end up with, even if you're completely jank-free in the trace, you're going to end up with this uncanny valley from a user experience point of view where the document will never feel like it's sticking to your finger. And so there's a whole group of people trying to do what we call scheduling, which is coordinating input and the frame generation together so that when we do make a frame, we make it with the data that counts. And Tim Ansel is going to be talking about this tomorrow. Key concept is on glass time and rendering toward the glass time rather than rendering based on now. It's crazy stuff, but it's super important to making a platform that feels smooth rather than that is technically smooth. It's like the last 5%, if you will. So we're getting toward the end of the things that are going on around 60 FIPS, fortunately. When we came into the year, the compositor, all this stuff about scrolling was actually really costly on its own right. To scroll New York Times up and down, just not even involving Blink at all, was 12 milliseconds a frame. Just like, that leaves Blink with, what, like 4.5 milliseconds, right? Like a really tiny slice. You can't do anything interesting in 4.5 milliseconds. So we've been trying to put the compositor on a diet and shrink down its overheads. And we've made really great strides there. We need to go further. And all this time that we're getting and winning back from the compositor goes right into Blink, into time that you can spend in JavaScript doing whatever it is. Okay. There's one other thing. Remember throughout this talk, we've talked about sort of rasterization as the root of much evil, and the fact that to fix that, we introduced this concept of layers. And then because of this concept of layers, we now have a slow thing in Blink that leads to needing a whole new architecture on layer squashing, and painting becomes slow. And all of this, it all stems from raster. So this is the root of our current architecture, I would posit. What if it was like that? What would we build instead? It turns out that there's an awesome group of people in the Skia team that have a way to rasterize using the GPU. And this is not, in the industry, a novel thing. Most of our competitors have been GPU rasterizing for a long time, and we're kind of late to the game. The reality is a GPU rasterizer is typically 10 times faster than the CPU version. But it has a lot of rough corners. Some content will go horribly slow, and on some machines, it'll crash the machine, it'll reboot the kernel, really bad things that make people unhappy. So to ship a GPU rasterizer is really the hard part. You have to figure out how to find out the unknowable. You have to launch to a whole lot of people in order to figure out how you're going to mess up their machines or mess up their pet websites, and then learn from that and iterate. And this is particularly hard because the GPU ecosystem and the content ecosystem is so diverse that our typical sampling techniques, where we'll deploy to 1% of users, doesn't really work. Now, the GPU team has some experience in doing this, and essentially the way we do this is with staged rollouts. We start with one platform, we add another platform, we add bits of that platform. We're going to do this with GPU rasterization on Android. But we need a little more help than just doing it on Android. We're actually going to start with a small set of devices because we don't want to reboot people's phones. And we want it to always be faster. We're not really comfortable with slowing down dig.com on people's browsers because it would really catastrophically. So we're also only going to trigger GPU rasterization just for a little while based on a magical viewport string. And this was arrived at with a lot of consternation. The general thinking is we need a small subset so that we can get it going, and then we can broaden this subset over time. The good news is rasterization strategy isn't visible to the platform. You can't see this. So this is a matter of just performance characteristics will vary from device to device. I would say we really would love your help in this area. The biggest concern here is your pet site going better or worse, and your machine rebooting or becoming unstable. If you have any Android device and you're willing to dog food for us, please do, and file bugs against us. We don't like that we have to do this in a staged way. We'd love to get it further. The only way to do that is with dog food, basically. But the key thing here is this is one of these examples of us trying to say, we're going to take something that we believe to be incurably slow and try to make it fast. Are there other things in Blink that we think are incurably janky? I don't know. But I think that we should at least test our assumptions here. Because we've seen over the last 6 months that against this many people, very few problems can hold up to the incurable label. So with that in mind, one final time I'll pester you with this goal. We want these mobile apps to be intuitively smooth. And frankly, we're getting there. Chrome 30 was not worth considering. It was terrible. Seconds per frame. Chrome 33, this is for inbox app. It was hitting 18, 20 milliseconds a frame, which is not quite enough to hit 60, but it was in the FIPS territory, right? Getting there. 36 is really close. We're at 10 milliseconds. We're hitting 60 FIPS for that demo. And we've got line of sight to another 3 or 4 milliseconds, probably more even. And this is 8 months of work, 6 months of work. You can argue about the details, but I think there's a huge power in this many engineers all motivated to just make it faster. And I think that that is really the right thing to do here because we got a great platform. So we want to try to make it fast. So then you might start feeling heady and you might go, oh man, this is getting in my head. We made it faster. So let's start deleting things. Like let's delete this thread. Because the thread itself is a mixed bag, right? You've got threaded scrolling, but like it's eating CPU time and to be frank, it's really easy to fall off that fast path. So let's delete it, right? And I've actually made that argument a lot, in my more emotional days. Here's my reasoned way of thinking about it, is there's nothing wrong with a fast path in our platform, right? Crankshaft, right? There's nothing wrong with that. But the key thing is it's got to be separate from the platform itself, right? The platform itself has to function. And it has to be rational. In the urgency to retrofit the thread and all of that scrolling and layering stuff into the platform in order to get mobile out, we kind of let the platform become a little irrational. And from this comes the on-scroll events not firing and all of these complexities that mean that there's this thing called layers, but it's really not part of the platform. If we get it back to a place where the platform behaves rationally, then I see no problem with there being a compositor thread that gives you a special boost when you want to scroll. But our first order priority needs to be to get the platform back to a place where when you have a mock from a designer and you want to make it work, there does exist a way to do it with our primitives without any magic. And from that, you can kind of get sort of like Nat Duca's guiding principles that he uses to criticize things. So I already talked about sort of everything that you get from a designer should be implementable with our platform. That's not the case today. It should be. We have work to do. Similarly, it really needs to be the case that no matter what you are doing as a front-end developer, you need to have available to you a palette of options that are all jank-free. So we have those for animation. We have those for different kinds of things. But there's still too many foot guns that you can use that create 50s, 60s, hundreds of milliseconds of work, especially around creating new bits of DOM or bringing in new bits of JS. That's inconvenient because when you press buttons, that's sort of what happens, right? You interact with the page. And right now, that's catastrophic. There's sort of this litmus test that comes from that, which is when you look at any given piece of code, you can sort of inspect it and say, the developer had this intent to change this pixel on the screen. Or they changed the body of the page to be blue. Is the work being done by the browser proportional either to the amount of change or limited by the size of the viewport? So if the screen's screen-sized and the document's really tall, the mental model of the developer really is that the work is proportional to what they see, and they don't see below the fold. So they sort of think that that's free. And that's not the case right now in so many parts of our code. And we need to sort of clobber our code back into submission here. And so repaint after layout and some of the layer work, all of these are thematically tied to this. You've heard a couple times how these themes, these silos between our teams become an issue. So you've got the performance between recording a picture in Skia and Blink and that being a bottleneck, or the compositor and Blink making layers and that being slow. We need to always keep challenging that, keep an eye on it, make sure we're measuring it, because a lot of the times you'll have that core kernel that's fast. And we've been trapped a lot lately by realizing, oh my God, that's not really the problem. Just keep silos in mind. And finally, I said before, but I really want to emphasize this, performance is something you measure, and the way that you make performance better is you build consensus between people. And the only way to do that is with tools that we all agree work well and that we agree on the values they're producing. It's a pain in the butt. You can always run perf on your local computer and get a number and make your local change. What's a pain in the butt is being able to say, I ran perf and you agree with me that my conclusion is correct. We have great solutions for that in the tracing space. We don't have it for sampling. I think that's a liability. It holds our team back in our velocity. So in closing, I want to give 3 challenges to everybody, sort of as demos that we want to make awesome by the end of the year, or sort of like, maybe when these are done, you'll never see me again. That would be great. Pull to refresh is a great one. It drives a lot of weakness around the scrolling not being, the compositor thread hookup being poor in the platform. So let's get a great pull to refresh. Infinite scroll. Right now you can either be jank free or you can checkerboard. You can't be jank free and checkerboard free. Let's fix that. That's going to bring up a lot of issues around DOM creation being slow, recalc style being slow, painting needing GPU rasterization. It's going to drive a lot of scary, but productive scary. And the most scary one of all is this notion of, hey, let's be able to click on a button and have that bring up a whole new UI, maybe a dialogue or something, that as it comes up, it's animating, and you've got spinny things, and it's all jank-free, and the whole main thread continues to tick at 60 hertz, even though we loaded new JS, even though we loaded new HTML, even though we had to recalculate the style on 10,000 elements, half of which were invisible. We can't do any of those things right now. Until we can, it's going to be very hard for people to make nice, silky smooth web apps. And I think we want to at least chase these visions until we prove that it can't be done. So I'm going to shut up now. If there are any questions, let's have at it. And otherwise, thanks. It's a quiet room.
So in the performance test cases you brought up, you mentioned the key silk case. So my sense of looking at some of the data is that they're intended to be more forward-looking than the key mobile sites data that we have. And in fact, the numbers I've seen in performance measurements there differ. But the averages on the key silk cases differ from key mobile sites.
Yeah.
Is the intent to be more forward-looking?
So just saying back the question so everybody hears it. The question was basically, there's some concerns about the silk case, the pages in the silk cases being a little bit different than mobile website cases, and what the heck's going on there. So the thing to say about this is, we have a content problem. Too few people have succeeded at making web apps, and we as browser authors are trying to make the browser faster. We don't have much time to make web apps. So we have this chicken and egg of, we need better data to drive our team, but to do that we need to get the browser better. We've erred on the side of having a baseline page set that's pretty Spartan, which is the current silk page sets. That's maybe not the ideal one, with the intent of trying to get an ecosystem booted up. My genuine hope is that within 6 months we will have some content out there publicly that will be a lot more representative and be much more full applications, and those will go right into the silk page set and make our benchmark, sort of automatic benchmarks, a lot more representative of where we're going to go. One other key thing to mention about that is mobile user agent sites still mostly just scroll. So you have to, when you're looking at something that's mobile user agent or in the mobile, what's called the key mobile sites page set, you have to think, is this needing to process scroll through JS every frame? Or is this just a scrolling site? Is it still basically just a document that you're interacting with? The thing where our platform is failing or very fragile, and the thing that we need to move forward, is the case where JS is running every frame and doing interactive things. So for some people's area of focus, there's no distinction. But especially in the graphics and the rendering area, you really need to focus on the one where, even though we have less content there, you need to keep your eye on that one more. All right, thank you, everybody. I'll be over in the corner if you want to yell at me.